Okay, we're going to be talking about stoichiometry and solutions. Stoichiometry and solutions. So now we want to, most reactions happen in a liquid. So let's take a look if we have, for example, we've dissolved some salt in water, so 2 moles per liter of salt. Remember that in the water, the ions are going to dissociate, so you don't have a full sodium and a chloride sticking together. They're floating around as separate ions, sodium and chlorine. So the dissociation equation, like you know, should look like this. So now we can talk about the concentrations of the ions. So let's see what that might look like. So if you talk about the stoichiometry, which means that number in front of the molecule or the ion in the reaction, you can see that the reaction was a 1-to-1 ratio. So for each of the ions, so we can say the same as the concentration of the salt. If we have something like barium chloride, where you have 2 chloride ions for every 1 barium, so you're going to have twice the concentration of barium to chloride. Sorry, twice the concentration of chlorine to barium. So let's take a look at some examples of how you could do stoichiometry in solutions. So here's our first example. It says, calculate the concentration in moles per liter, both potassium and chloride ions in a solution where 19.8 grams of potassium chloride is dissolved in 100 milliliters of solution. Oops, I'm going backwards. Okay, so first thing you need to do is write that dissociation equation out. Then you're going to look at the number of moles of potassium chloride. So we have the mass. This is not concentration. So now we need to figure out the concentration. And we know that concentration is, we need to find the moles. So let's find the moles. So 74.55 grams comes from the molecular mass of potassium chloride in every 1 mole. So then you have 0.266 moles of potassium chloride. Now we want to figure out the concentration. Concentration is moles over volume. So here you get 0.266 moles over 0.1 liter, and that is 2.66 moles per liter. The molar ratio, 2.66 moles per liter times, for every 1 mole of KCl, you have 1 mole of chlorine. So therefore you will have 2.66 moles per liter of chloride ions, or simply you can just write it underneath. So for the most part, there are going to be simple dissociations like this. You should be able to do simple math to figure it out. Or you can write it out as a full equation. Either one works. As long as you write your final answer, stated with these square brackets, the ion on the inside, and its molarity with a capital M, or moles per liter. Okay. So let's take a look at another example. So here you're going to have, obviously, you have your barium chloride with 2 chlorines for every barium. So you have a concentration of barium chloride ions in a solution where 19.8 grams of barium chloride is dissolved in 100 milliliters of solution. So now, again, dissociation equation, make sure it's balanced. So when you're writing it out, make sure that you balance the equation by writing a 2 coefficient in front of the chlorine. Number of moles of barium chloride. So we have the mass, we need to figure out the moles. So for every 1 mole of barium chloride, you have 208.23 grams of barium chloride. That will give you 0.0951 moles of barium chloride. So now we need to find the concentration. Concentration is moles over volume. So here is your moles over volume. That gives you 0.951 moles per liter. The molar ratio. So for barium to barium chloride, it's the same, but you have twice as many chlorines as you would have barium and barium chloride. So the concentration for barium chloride is twice that. So this is how you could write it out. So 0.95 times 2, or you could simply just write it underneath because you know it's twice that concentration. Okay, and make sure that you always write your final answer. There you go. So you have worksheet 5 that we will work on tomorrow in class.